from a cornflakes box or a sweet box like this is, and you can just cut a small rectangular strip. So small, about 1.5 centimeters in breadth, 5 or 6 centimeters in length, and you'll be able to use this beautifully. What we then do is take this beautiful paper punching tool, which all of you I'm sure love to play with, and try and get a hole as close to the middle as possible. So both in the length as well as the breadth, more or less in the middle, and we have a beautiful kind of spinner like this. Now what do we do with this? We take a small pin that we have here, put the pin through the hole that you've made in the spinner, and attach the pin to the eraser end of the pencil. So that's the only function of the eraser here. It makes it easy for us to attach the pin, and your toy is ready. So what we take next is any kind of twig. It can be an ink refill, it can be a skewer like this, it can be an ice cream stick. And what we do is we hold the pencil with our left hand as far from the notches as possible, the right hand holding the skewer quite firm, and we just start rubbing on it, rubbing along the notches, and we get a beautiful spin on the spinner. So it actually starts rotating, right? So you can do various things. One of the tricks is, I do it this way, it rotates this way. I do something else. Still rotating in that direction. So sometimes you're able to change the direction of the spinner. Doesn't work with this one. It works with another one that I've got for you here. So this is one of the things that's quite random about this toy, which makes it very interesting. It's a very complicated bit of science that's going on, but it's a very exciting toy to play with. So I have another identical pencil. You're again seeing it spin clockwise. Still spinning clockwise, clockwise, and there you go, see? That's the marvel of this beautiful gadget. It's a Native American folk toy, believe it or not, made almost 200 years ago by Native Americans, and they call it Gee-haw whammy diddle, because they would say G and it would spin in one direction, and they would say haw and it would spin in the other direction. So G and haw in their language meant left and right. So this was the Gee-haw whammy diddle. You can see I'd made one earlier, this one earlier, this one right in front of you. It's a great activity to just have fun with. Now, it's a very simple activity, of course. You must be wondering what's going on. Why is it spinning? And we can talk about the science a little bit over here. So when you have these notches, they create vibrations, and the vibrations are causing the spinner to spin. So these are random vibrations causing perfect circular motion. Now, how does that happen? That's not very well understood, although there is a theory that you need a nice circular hole. You don't want it to be too uneven. So that's why we've used the paper puncher to make a hole like in this spinner. And that's why as the spinner vibrates, the needle keeps hitting the sides of the cardboard and spins. Arun is asking, do longer pencils need longer notches? Not really. The notches need to be of a size that are similar to what you are rubbing with. So the width of this skewer, for example, is about 2 or 3 millimeters. So that's why the notches need to be similar to that. I have another pencil here, for example. If you notice, the notches on this one are slightly narrower than the notches that I have made today. So here with this one, because the notches are a bit narrower than this skewer, it gets stuck when I try to rub along it. So you don't want them too deep and narrow. You want them slightly wider, but you do want them V-shaped, not U-shaped, so that you're creating a bit of vibration. Yeah. So you get these vibrations, the pin goes randomly all over the place, hits the sides of the circle that the puncher has made, and gives it motion in one direction or another. So I hope you guys are enjoying this and you're making it yourself. I've been doing it for a while, so it takes me only 5 or 6 minutes to make it. But when children work with it for the first time, it may take them, 15, 20 minutes going through 2 or 3 pencils to get these notches right. So this is a beautiful spinner. You can do very many interesting things with this. For example, I have this piece of square color. What can I do with that? Let's see. I'll take some glue. So you can see that this is the 7 colors that we talk about, the rainbow colors. We've made a square piece out of that. Please ask your questions. We'll be happy to answer them for you. Engage with us. Share this Facebook Live on your timeline and tag us in your comments in that share, and we'll be able to send you a free kit. So that'll be something that you can play with right in your house. It'll come at your doorstep in a week or 2, and you'll be able to make this right here. If you want to make many more such toys, just come, subscribe to any of our workshops online. It's called OnTact. Go to our ThinkTac OnTact page, which is also there in our comment feed for this Facebook Live, and you'll be able to register for a multiple number of these themed workshops. We've offered acids and bases, we've offered force and motion, and we'd like you to take any one of those to start off your journey in science this summer. So what I've done is I've pasted this so-called Newton disc. It's got 7 beautiful rainbow colors, as you can see. I've pasted it on a piece of cardboard so that it's kind of firm, and I have a beautiful center here. Does the cardboard need to be thin? Ideally, we want it to be thin cardboard. So like the ones you'd use from a cornflakes box or a toothpaste box or a soap box. Manjusha is asking that. So I was just saying that as a bit of a hint. You can use any thin cardboard. You can try with thick cardboard as well. But as the weight increases, it becomes harder for the spinner to rotate. So try and use thin cardboard. Here the center is already marked out for us. So I just make a quick hole there. And now we try this with this square right in the spinner, right? So now when I rotate it, the square rotates, and if it spins fast enough, I don't know if you're able to tell, but the colors are kind of merging. What you'd expect when these colors mix, that you're getting an almost white kind of spinning wheel. It's amazing that the disc is square, but when it spins, it looks circular. You might wonder why that's the case. We'd like you to figure that out and let us know if you can tell us why when a square spins, it still looks like a circle. And the colors kind of merge to become a beautiful light, much lighter shade of the colors there, and almost white in color, right? So you can also make a circular spinner. How does one do that? You can use any kind of circular piece, like this tape roll. I take any kind of pen or sketch pen, mark out the circle, and cut that out. So if you don't have this color wheel already ready, you can always cut out a circle using any kind of circular object, a bottle cap or a tape roll or any such thing. You don't want to make them too big, as I said before, because the weight becomes more and it becomes harder for something to spin. Once you've done this, you could do various things like we had done. You can make a pie chart and make a ring like that, or you can just, mark the center and then mark some dots around. You can use a different color if you want and make it colorful. Why am I marking dots? You'll try and play with it and see why that's the case. Yeah. So more or less evenly spaced dots around a kind of ring. And then we again make a hole on this one too. You can see the kind of paper this is causes the pen to smudge a little bit. You can use cardboard that kind of more absorbent if you want, but this should work fine too. So the same thing here, we just put this in the spinner and the dots become lines. Maybe you're not able to see them too clearly. If I do it slower, you might be able to tell that what were dots suddenly look like lines. So that's why I made just dots, so that when the dots rotate fast, it looks like you're creating a circle out there. So you can try various shapes, you can try optical illusions, you can draw spirals, and you can try various kind of combinations with your spinner. We can also, you've noticed that I've got another spinner already cut in a circular shape here, and I can use that too. And it does the same thing as the square spinner I showed you earlier. So again, spinning it fast, again the colors seem to merge to become a white kind of color. So there's various things you can do. Different spinners, you can use a different kind of pencil. For example, here I have a pencil that has no eraser. So what I've done is I've taken a safety pin, I've put the spinner in the safety pin, and I've just taped the safety pin to the end of the pencil. So there's no actual need of an eraser, it just makes our life a bit easier. Here I've used some tape. So even though the pin is not now in the center of the pencil, but at the edge, I'm still able to use a pencil without a eraser to make a beautiful pencil spinner again. So this is an activity that has actually resulted in people writing many papers on it. The American folk toy name that I was telling you about it, Native American name, it's called Gee-Haw Whammy Diddle, and you can search for it online, you'll get many videos of it, and this is what it is. It's had 6 or 7 research papers written on this, including PhD theses done on this toy about why it rotates in a certain direction and sometimes rotates in the other direction. So you can just say Gee-Haw and get it to change direction. So these papers have been written trying to explain that, including by Nobel laureate physicist called Richard Feynman. You'll get the paper online if you search for it, and still not been able to perfectly explain why the direction changes. So it's a complicated physics going on there with the vibrations creating circular motion, but it is something very fun to play with. We're transferring some energy by creating vibrations, creating circular motion, and we're able to work on simple materials like this pencil to do this. What was originally done, of course, was probably using something like this, which is a twig of wood. You can put any kind of, we can use the same thing, of course, here, where we put the wood, where we put the pin in the wood with the spinner and do the you can notice that the pin is probably too tight, so then the spinner doesn't have enough place to rotate. You move it further back and you're able to get the spinner to rotate. So you can make it just with a piece of twig that's fallen outside. Now, once we were in a workshop where we made this with children, and they decided on the following. We hope you're liking this video. We'd like you to give your comments, ask questions, share this video on your feed, and you'll get a free kit sent to you if you just share this video on your Facebook page, just tagging us in your comments for that share, and we'll be able to send you one of these kits where you'll be able to make at least 2 activities inside that kit that you'll be able to make. So we hope you'll do that so that a lot of you get kits coming straight to your house and then get you excited and enroll to one of our programs where you'll be able to make many of these over the course of 2 or 3 weeks where we do these programs with children online, face-to-face in Bangalore, and many, many more such options. So this was using a piece of twig. Now, when one of our children came to our workshop and made this and realized that vibrations, so I don't even need the notches, right? I can just tap the pencil and it rotates. You might wonder what the notches are for, but they were still fun to make, and you got a very fast spin with it. But once some child realized that the vibrations are causing this spinning, they decided to use some very simple other materials. This is a bicycle spoke, as you can see. I'm putting a bead in there. You'll just realize why. I'm putting a bead in there so that the spinner doesn't fall out. So I put this spinner down there. And then I have these marvelous magical things called magnets, which I can just put on the cycle spoke here. So now the magnet just sticks on the spoke because it is made out of iron. But I can spin the magnet and it actually starts going down the spoke and the spinner starts rotating. Now how does that happen? So the child realized that even without the spinner, if I take the spinner out and put the magnet in, you'll notice, if you look at the bottom, that the spoke vibrates beautifully. So if while spinning the pencil, while rubbing the pencil on the notches, it vibrates, causes circular motion. The same thing should happen when I put a magnet down a spoke. So that's exactly what's happening here. I put a magnet down a spoke and I'm getting the spinner to rotate. You can have even more fun by putting a small piece of straw on top of the magnet, and I rotate it then, and we see what happens. The straw actually almost levitates at a particular height, and it almost seems to do that at the same height every time. Lots of fun indeed. You can even turn this around and do the same thing the other way around, and the entire assembly spins. And I didn't put my hand here for the magnet not to fall. It just doesn't fall. It wants to stick to the iron spoke for as long as it can, and it doesn't fall. So you can have a lot of fun. Now you might wonder what will happen if I use, say, 3 magnets. So we'll try that as well. So here, 3 small ring magnets, very easily available. Also there in many of our kits. We use magnets as magnets, we use magnets as weights, we use magnets as decoration because they're lots of fun. So here with 3 magnets, it took so much more time to come down. And we still got a beautiful spinning of the spinner down here, as well as the levitation of this beautiful straw piece up here. So lots of things you can do with these spinning things. You might wonder what's the use of having a very central hole. So we can try something else. What happens if we make an off-center hole? So I've just cut off a bit of the spinner. Now the hole is quite off-center, and we'll see what happens if I try and use a off-center hole on my spinner as I try to spin it. Quite a bit harder for it to spin, you'll notice, because one side is heavier. But if the spinner is made well enough, it does rotate. So it's like your door. Your door, even though it's not hinged in the middle, it still spins quite nicely if you pull and push your door. So that's what's happening here. The hinge is at one end. It's tougher for it to start. It's always dangling below like this. But once it starts, it can spin quite nicely with an off-center hole. The other thing you can do is a beautiful double spinner exercise. So you can take, say, one spinner on the spoke, another spinner on the pencil, and use the spoke to rub the notches, and you can see both the spinners rotate. So the spoke is vibrating by virtue of it rubbing on the notches. The pencil is also vibrating, and therefore both the spinners are now rotating. So you have yourself a nice double spinner as well. So these are the kind of fun things we can do with force and motion. We can study some rotation, we can study vibrations, we can just have fun with these simple materials. We've used magnets that come down at different speeds along this, and we are able to do a lot of interesting things with just these simple materials. So we hope you're enjoying this activity. We hope you've shared it a lot with friends. It was good to get questions from Arun and Manjusha. I hope you're sharing it with all your buddies, and you're able to get those shares and share it with us. Tell us, tag us on your comment feed, and we'll be able to send you one of these free kits to make one of these lovely activities. You might wonder when it doesn't. There could be times when it doesn't spin. And why would that be the case? So you'll notice that I'm holding my hand far away, I'm holding this close by, and then it spins very easily. Now what if I hold with my left hand here? Much harder for me to get it spin. It still does. If I put my finger underneath, it's even harder to make it rotate. So it's clear that we need it to vibrate, and therefore we need to keep the left hand, or the hand that you're holding the pencil with, as far from the notches as possible, so that the end of it vibrates easily. The other common mistake people make is holding the skewer far away, or the ice cream stick far away, and it still works. Not really, right? You need a firm grip. So you need to come slightly closer, hold it nice and firm. You don't have to spin very fast, but you have to press down nicely, and you get a beautiful, nice spin. So we hope you make multiple pencil spinners like this. The pencil that you write with in your class can be made into a spinner, so that when you're bored in class, you just play with this and maybe be one of the people who explains how something like this works later in your life. As I said, pretty complicated physics in this one. You can learn a lot of simple physics with this one. And that's how all our activities are designed, that you use very simple materials. You're able to play and tinker with them. You can change the size of the notches. You can make more notches, less notches, different sizes, use different pencils, use different materials, and see if you can make multiple pencil spinners like this. What would be nice if you use a twig is you can have a branch, make notches on each one, put multiple spinners, and see if you can make a multi-spinner on a twig like this. So we hope that you have enjoyed this show. We hope that you'll sign up for one of our summer programs. Please do. They're a lot of fun. Things get sent straight to your house. There's 9 hours of interaction with our educators. You'll be able to make multiple things. There are 4 themes on offer right now for the ONTAC program this summer, starting with acids, bases, and salts, and force and motion. Those are 2 of them. Then matter and animal movement come up later in May as well. So as your holidays are really heating up in many senses of the word, we hope that you'll enjoy doing these science activities, play a lot with these materials, and come and join us for one of our workshops. Please share this video. As I said, if you do it while it's live and tag us in the video, you'll get a free kit sent to your house. We hope you've enjoyed this show. My name is Procheta Malik. I've been working here from ThinkTac right from its inception 2 years ago, and we're lucky to be able to use a space like this, so C.V. Raman's old home here in Bangalore, to conduct a lot of our workshops and activities. So if you're in Bangalore, I'd recommend you register for a workshop here face to face. But if you're anywhere else in India, we'll still be here. We'll work with you wherever you are and make a wonderful selection of activities in various scientific themes. So keep in touch and stay posted on this site for the next TACLive event. In the meantime, go online, register on the ONTAC page. Goodbye.